Okay, here goes. We're going to run through that your turn, have a little look at what we've got. Starting with the equation 5y plus 10x minus 7 equals 0. We want it in the form y equals something. So let's add 7 to both sides. As I say, lots of you will do this quite naturally, all slightly faster, slightly more steps in one go. I'm going to take 10x off both sides. So that's going to give us 5y equals minus 10x plus 7. If you have written 7 minus 10x, that's fine. As I said, it's just easier to work with it in this form. Get rid of that 5. So we're dividing both sides by 5. So y equals minus 2x. And I'm doing that all in one step this time. 10 divided by 5, easy enough. Plus 7 over 5. Reading off, we have the gradient equals minus 2, and our y-intercept. What's our y-intercept? Our y-intercept is 0 along 7 over 5 up, and there's your answer. So hopefully that matches up with what you've got. Now we're going to move on. We're going to do an example of something slightly different, which is going the other way. So we might get given a line equation and be asked to put it into that form. So this is the opposite operation, going the other way. So let's start with y equals 2/3 of x plus 5. Now, it's up to you what order you do this in. I recommend taking that 5 first. Let's deal with that bit. So we end up with y minus 5 equals 2/3 of x. Now, we need to deal with the fact that this is an over 3 here. We don't like that. That's the same as divide by 3. So we're going to times by 3. That's important because at the end I want my answer to be in whole numbers, which it wouldn't be if I just move my fraction over 2. Timesing this out by 3, we get 3y. Don't forget, we've got to multiply everything on this side by 3. So minus 15 equals 2x. And now we can take our 2x off both sides. What do we get if we do that? We get 3y minus 2x minus 15 equals 0. And there is our final answer. We've got it into that form. All our numbers a, b, and d are all whole numbers. They are 3, minus 2, and minus 15. It does not matter that there are minuses here, but pluses in that form. That's absolutely okay. Nothing said that we couldn't have b and d being negative numbers. Now, second example of that. So we're going to move down to this one. No, this one's a wee bit harder because we've got a fraction in both positions and their denominators don't match up. So I'll show you what to do with that as well. So here we have y equals minus 3 over 4x plus 2 over 5. I'm going to do the same step. I'm going to take the 2/5 across. Now, that there gives us y minus 2/5 equals minus 3 over 4x. We want to multiply everything by something that will get rid of the 5 on the bottom here and the 4 on the bottom here. Now, the only number I can think of, well, the smallest number I can think of that's in the 5 and the 4 times table is 20. Multiply everything by 20 and see what happens. So that gives us 20y minus, now, timesing the top here by 20, we get 40 over 5. 40 divided by 5 is 8. 3 times 20 is 60. Divided by 4 leaves us with 15. And we've got the minus sign still there, and we've still got the x. Now we add 15x to both sides. So that leaves us with 20y plus 15x minus 8 equals 0. So that's a bit of a harder example. The two fractions make this a bit trickier, and you'll find those in the red questions. Some similar things to this in the red questions and the very end of the orange questions when you're working through them. Okay, so another one for you to do. Here it is. Have a go at that one, and I will run through the answer to that in just a moment.